truck, boat, car, lawnmower, forklift, marine applications, stationary generator engines, agricultural, anywhere where the engine has an ECU in it that can be read, you can, within reason, modify.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode we're joined by James O'Connor from the File Service in Australia. As factory engine management systems have become increasingly more complex, replacing them with an aftermarket standalone ECU so that we can tune them has become increasingly difficult, sometimes impossible. At the same time, the aftermarket has always stepped up to the plate, and for those who are capable of understanding the system and using it to its full potential, reverse engineering these factory engine management systems with software such as WinOLS is a viable solution. It's not for the faint of heart though, and it does require some fairly in-depth knowledge of both the binary editor software as well as how the factory engine management system works, and that is what we're here to learn about with James. James has had a long and deep history in the world of tuning factory engine management systems, starting as a master technician, basing himself around the Porsche brand among others, and he learned from some of the best in the business while he was in Europe. He now uses his knowledge to provide files and map packs that he sells to other tuning workshops all around the world as well as Australia. This episode goes deep into what's involved to reverse engineer a factory engine management system, some of the challenges that the factory puts up to make it more difficult for us to modify their calibrations, and what the specific software and hardware we're going to need if we want to get into this business is. Before we get into our chat with James though, for those who are fresh to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune both factory and aftermarket standalone engine management systems. We also cover topics including performance engine building, motorsport wiring, race car driver education, race car setup, data analysis, and even fabrication. All of our courses are delivered via online video modules that you can take from the comfort of your own place. So there's no need to travel in order to learn with us. Now, relevant to today's topic, obviously this is a little bit deeper because we are talking about reverse engineering factory engine management systems with WinOLS. We've got an upcoming course that will cover this in more detail. However, once you've done this, you still also need to understand the tuning process. And this really comes down to our EFI Tuning Fundamentals course. As its name implies, teaches you the fundamentals of EFI tuning, how the engine management system works, how the engine responds to both fuel and ignition, essentially what we're trying to do when it comes to optimizing a tune. And also we've got our practical reflash tuning course, which teaches you the process of reflashing or remapping a factory engine management system. Now, this particular course is covered really or focused really on commercial software. However, it's still totally applicable to those who are using map packs and WinOLS in order to perform their tuning. And we know that for the average tuner, when it comes to reflashing their first engine management system, it can be a little bit daunting knowing what to do first. And what we've done within this course is developed a simple 6-step process that you can apply to any tuning job, irrespective of the engine management system, the tuning platform, or the specifics of the car. By following this process, it's going to ensure that when you get to the end, you haven't overlooked any critical steps. It's going to ensure that you get optimal power and torque, but most importantly, great reliability. That course also includes a library of worked examples where you can watch the entire 6-step process being applied from start to finish on a variety of different tuning platforms and cars to give you a broad understanding of what is taught within the course. Now, all of our courses also come with a 60-day no questions asked money back guarantee, so there is zero risk of getting involved. If you decide it's not right for you, no problem, let us know. We'll give you a full refund of the purchase price. And as a podcast listener, you can use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course, and I'll put a link in the description to those courses and that coupon code. All right, let's get into our interview now. All right, welcome to the podcast, James. Thanks for joining us. And as we always do, I want to get started by learning a little bit about your backstory. And I'm guessing here from the accent, British to start with?
Well, it's funny. Everybody thinks I'm British, but I actually was born in South Africa, and I grew up in Townsville. And I moved to England when I was about 10 or 11 years old.
Okay.
Yeah. And then I've lived there for 22 years, something like that. And I said to my wife, I'm not dying in a wet, cold country. I'm coming home. I'm coming home to Australia, and I think I moved back in 2002.
All right, well, let's find out a little bit about your history with the automotive industry. So how did that all start? How did you get your interest in cars in the first place?
I actually started off as a carpenter's apprentice when I was about 15. I left school when I was 15, and unfortunately I didn't drop it, but someone dropped a sheet of plywood on my foot and took my toes off, or took a couple of toe off, and smashed all the other ones to bits. And the guy sacked me. So I didn't have any work, and we were a single parent family. So I straight away went and got a job working for a Jaguar specialist as a mechanic, as an apprentice. And then I did my apprenticeship with Jaguar Aston Martin dealer in West Byfleet and passed there. And then I went on to work for a Mercedes Ferrari specialist in Horsham. And then I moved into London and worked for Porsche AFN for some years, and just basically became I think they call it a master technician there. And discovered that not all car manufacturers are created equal. So yeah, you can work for Jaguar and Aston Martin. You think that's amazing, but then you see the level of detail. I mean, that's in the 80s. I'm sort of old. I mean, I left school in 82. So Aston Martins back in the 80s had big carburetors, and we used to tune them with bits of tube. So then when I left Porsche, the 993 turbo was just coming out. And then I worked for myself from 94, 95, and I've worked for myself ever since. We basically in the UK did nothing but Porsches. And then when I came here, I worked for Porsche Centre Brisbane for about 8 months, a year, to sort of get my feet and find out what was what. And then I started up Bayside Performance Services, and we've been going ever since. But I can remember the first time I ever got a car tuned, which was back in the old days. We had the 964s, and there used to be a variance in performance with them. And there was a guy called Jeff Everett, and he owned a company called AMD up in Oxford. And AMD, as far as I know, were the very first people in the UK to offer any kind of ECU remapping, reflashing, chip tuning, whatever you'd want to call it. I mean, I suppose they called it chip tuning then because you did have to remove the chip from the board. And I remember driving 964s up to him, and he was squirreled away into this little barn around the back of his house. And he had a Maha dyno in there, and it was all, I mean, this would be 1994, 93, somewhere around then. It was an amazing thing to actually see him do. He's dead now, unfortunately, but he created an incredible product. And I suppose I got interested with him for quite some time. And then my company was responsible for selling TechR performance parts in the UK. So we travelled to Germany and saw their TechArts process. I mean, back in the 90s, TechArt and Gambala were, and Roof were huge businesses. And I met a guy there called Olivier Newman, who ran a company called Evertech. He did all the software for TechArt back then, so we sort of got going with them. And then TechArt sort of had a few issues with supply, so we moved to another company called TTE, where I met a gentleman called Ferdinand Peets, who was the first person who really introduced me to how it actually happened, how this process was done. Because up until then, nobody would show you anything. Like now, you can hit YouTube and you can Google, how does EVC work? How does this work? How does that work? Back in the 90s, nobody told you anything.
I think it's fair to say, even today, with the remapping of factory ECUs using the likes of OLS, which we're going to dive into, obviously, during this discussion, that there is a lot more information around today. As you say, there's YouTube videos and tutorials, but it is still shrouded in a lot of secrecy. And as you say, I can imagine back at the point you're talking about, this is just, it's just there's no information out there. Absolutely no one wants to share, and those who know what they're doing are probably making pretty good money out of this business. So they definitely don't want anyone else jumping on the bandwagon. Correct?
Yeah, I mean, you've got to remember back in the mid-90s, you could count the amount of people that could do this in Europe, like Germany and England, on fingers of two hands. I mean, we used to pull 993 engines out. If we had a 993 turbo in for upgrades, we used to send it to RS Performance, and we would literally box the engine and the ECU and send it on a truck to them. They would tune it on the dyno, and it would come back, and we put it back in the car. Jeff Everett started with the Rolling Road, and then there was a couple of others who sort of started, but then when did I leave? I left in 2001, 2002. Even then, I think there couldn't have been more than, say, 15 workshops in the whole of England that did it.
Yeah, I think the other thing about that is around that time, probably not dissimilar to when I was running my performance workshop. The access to dynos was not what it is now. I mean, just about every town has a bunch of workshops with a good quality dyno, and that just wasn't like that back in the 90s. And a lot of people are street tuning, and the quality of the results obviously was a bit more questionable these days. Dynos are still expensive, but they're at least accessible now, and you can get repeatable results, which is really important. Before we sort of dive too much further down this rabbit hole, I just want to sort of get a bit of a connection here. So obviously we understand there you're a trained master technician, obviously a lot of experience there, as you've mentioned, on the Porsche brand in particular. So is this about the point, working with these companies and people that you've mentioned here, you're starting to get your own interest in developing that interest in the tuning side of things?
Well, I wanted to find out how they were doing it, and I was intrigued as to how it was happening, because to my, I would take a car somewhere, I'd sit outside and wait, and then I think back then I was giving him £500 or £800 and going home, and I was just thinking, so how is he doing this? And then when I met Ferdinand, he said to me, come over to Germany and I'll introduce you to the guy who does my tuning. We had two guys then. One was called Buchner, and the other guy who had a company called Sportec in Switzerland. He said, and they'll show you what happens. And at the time, I had literally just moved to Australia. So I said, right, stuff it, I'm going to come back to Germany. And he introduced me to a guy called Bernard Jastafer, who created a piece of hardware called the Byte Shooter, which was it was the first of its kind. At the time, there was CMD, and I think there was Dim Sport Race. And Bernard Jastafer created this thing called the Byte Shooter, which revolutionized the tuning industry back then. And it was horrifically expensive, but it would read ECUs without you having to desolder EPROMs.
Right, so you're talking about this hardware interface to go between the ECU and your laptop, so you can read and write the information out of it.
Yeah, because if we wanted to tune like say for argument's sake, a 993 Turbo 4, we used to have to desolder the EPROM off of the board. It was a SOP 44, and it's soldered onto the board and glued down. So you essentially had to break the ECU open, flip it over, and then remove this device from a multi-layered board. And the hit rate was probably 9 out of 10. So every 10th one, you had to be ready to swallow the cost of a new ECU and a new programming.
I was going to say that does sound like a potentially risky and therefore potentially expensive process if it goes pear-shaped.
I remember the first GT2 993 I broke. Still to this day. I remember how much it cost me to fix. But when I was there, I met a guy called Buchner who introduced me to OLS. And he literally was tuning cars in a cowshed out in a place called Coblemore. And he sat me down and he showed me, and he spoke about as good English as I do German. I mean, I can order sandwich and beer in German, and that's probably about it. And he showed me how this piece of software worked, and he said, this is where you buy it from. And I think in 2001 or something like that, I bought my first license of OLS.
All right, let's just park that for a moment. And before we get into OLS and dive into what it is, what it isn't, and how it all works, back at that time, the cars were simpler than what we're dealing with today. And we didn't have the multitude of different electronic modules in the car that all communicate together over a CAN bus. So it was, because I was dealing with JDM vehicles around that same era, it was much simpler at that time to actually take the factory ECU, throw that in the bin and fit an aftermarket standalone, be that a custom wire-in job, or for popular models, often the manufacturers would make a dedicated plug-and-play. So I'm interested, what was that not an option for these Porsches that you're dealing with at the time? Because it seems to me like that would be quite a viable solution in that era.
Well, back then, I don't have any recollection of ever seeing an aftermarket ECU in a car. I mean, we did Porsche, BMW, Mercedes, and so on, but I mean, primarily Porsche. I mean, up until '93, Porsche were all K-Jetronic, and the only way we used to tune those was with a little product that you would plug into the warm-up regulator to modify control pressure. So you did have a little ECU that would pulse an injector to change the control pressure for the metering head. That allowed you to kind of tune them. I'm trying to remember the first time I ever saw an aftermarket ECU. We saw motorsport ECUs from Porsche when we did training, but we assumed obviously all factory stuff. I think the first time I ever saw an aftermarket ECU was here in Australia, and it was an old Haltech red box, E6X, and I was amazed that this existed because I'd never really seen it. I mean, when I came to Australia in 2001 or 2002, whenever it was, I was amazed at how many options of ECU there was, because that industry didn't really exist in the UK.
No, it's an interesting one, and we've talked on the podcast previously about this. I don't know what's in the water in Australia, but Australia in particular has been a hotbed for aftermarket ECU manufacturers. I don't know, I think there's probably at least 5 or 6 that sort of sprouted up around the same time. And I mean, yeah, the 90s, I mean, there were options there, but you are right. I mean, it's probably more the 2000s where these sort of came to maturity and we had more options and more quality options. So I just wanted to sort of get to a point there that aftermarket ECUs for those older generation cars, which weren't as technically complex, were definitely easier to install, and as we'll probably talk about, these days that becomes harder and harder. Okay, so OLS, you've used that term there. WinOLS, probably hear people call it WinOLS as well. Irrespective of what you're calling it, what the hell is it?
OLS is a binary editor, really. I mean, that's essentially what it does. It can take a binary read from anything. I mean, you could read the contents of a mobile phone SIM card if you want and put it into OLS, and you can essentially modify the binary code. It was developed, I think, back in 93, 95 by Axel Schroeder, and it's a piece of software that allows you to manipulate the machine code, and then back then we used to have to correct the checksum with it because the tools didn't do the checksum. EVC did the checksum, and it was incredibly complex. I mean, I remember buying it and looking at it and going, what have I just wasted my money on? You're a mechanic, you know how to fix gearboxes and you know how to build engines and change clutches. Well, what are you doing in here? This is all 8-bit this, 16-bit that, and I remember printing off the entire manual and putting it in a ring binder, and I said to myself, I'm going to just literally read a page until I understand it, and then turn to the next page and read a page until I understand it, and so on. And I'm going to go through this manual, and I'm sort of quite pig-headed like that. If I kind of put my head to doing something, I will try my very best to do it. I'm going to give up smoking. I was a 20, 30 a day man, and I was like, that's it, give up smoking. I've never smoked since, and that's OLS. Back then, there wasn't anywhere you could go that would teach you. EVC sold a product, and they said the support is in the help. If you don't understand it, you shouldn't have bought it.
So you're pretty much thrown in the deep end on your own with very little support. And I mean, within reason, that hasn't changed too much to the current day. You've said that this is a binary editor, and I mean, I'll just be super clear for those who maybe aren't picking up the breadcrumbs at this point, that we're using this now for modifying the contents of our ECU processor memory, basically changing the mapping. But it's not as easy as an aftermarket reflashing package, which has a nice user interface and
a big tree with everything.
displays fuel maps or ignition maps. This is essentially just that you're looking into the matrix, essentially, aren't you?
Yeah, and when you look at an aftermarket ECU, what you're seeing there really is just the essential components that the people who manufacture the software allow you to see. You would have I remember in ECU Flash, you used to be able to have advanced, beginner, developer mode. And I always used to say to people, whenever they're opening the software, put it on beginner because it'll overwhelm you the amount of stuff that's in there. But what you don't see in the background is all the stuff that actually makes the ECU work. You know, how does the crankshaft signal work? What's the routines and runs that make everything function? You know, how does it know which timing map to go to? All this. You see everything. So you see everything from the 0 to the FF at the beginning and the end, and you're able to change everything within those two address boundaries, which is the most dangerous part of OLS.
So you can get yourself into a lot of trouble if you don't know what you're changing and the effect of that change.
Yeah, if you go into an out of date area, or you catch an axis by mistake, or you I don't know, I've done it before. I've just caught my finger on a key, and then I'll do a check through and I go, how the hell did that change come from? And you thankfully change it back. But you know, it's a piece of software that allows you to do anything you want within there, and there's no hand holding. It doesn't protect you in any way. It just says, away you go.
You've mentioned that it can be used for basically modifying the contents of anything. You brought up the mobile phone example. Was this developed solely for the automotive aftermarket industry, or is it just kind of that's what it's become synonymous with?
It was developed specifically for engine control units back in the 90s to modify them, but it has been used. I've heard of people who use it for mobile phones. I've known people use it for all sorts of other shenanigans. But yeah, what it does is it has a very good database built into the back end of it, which will allow you to, and the problem that a lot of people seem to have with it is that they create a project and versions within it. So if you import a piece of software in there, you need a reference version to work out what you've changed, because there's nothing to reference again. So people will create a project with a tuned file and then go, oh, I can't find this and that. And I said, yeah, because you need the original to compare against them. And also years ago, you needed the original intact so that you could get the correct checksum calculation, because a modified file would have that checksum calculation changed. So essentially, when you exported the file to program it in, the checksum would fail because the routine wasn't correct. And EVC just worked. You know, it was the only thing back then that I think I tried. I had to go on dim sport race, and it didn't allow you the functionality within it. And the more I use, I mean, I've been using OLS now for 23 years, and I still find tricks with it that are just, you know, there's people who use it that are far cleverer than me. And when you see them use certain scripting functions and advanced scripting functions, and you're just like, that's clever. I didn't even know that existed. And then I use it and just go, yep, I'm on this now.
You've brought up that term checksum, and I just, for those who are maybe wondering what the hell that is, we are going to deal with that because it's quite an important element, but we'll deal with it shortly because I don't want to get too far ahead of ourselves. So we've sort of defined the software package and what it is and what it can be used for. But it's not just the software package on its own. We also need some hardware that goes along with this to sort of complete the package and be able to actually read, write, and make modifications. So can you talk us through what else we actually need?
So when I very first started, the first thing I had was a thing called a Gallup 5, which was an EEPROM reader. There was a few different companies made them. Batronics made one, Gallup made one. I can't think of the others. So we would physically remove the EEPROM or the ROM from the board, and we'd put it into a little reader, and it would read the data out, and it would then we'd import the data into OLS. We would modify that. Then we'd take the little chips, and I've still got it somewhere, a little UV cooker. I don't know if you remember those, the little chips with the UV window in them.
Before my time, I'm happy to say.
So before flashing, you'd actually physically remove the ECU and the chip, and on the back was a little black sticker. And if you peeled the black sticker off, underneath was a little window where you saw the memory. And the memory would be erased by putting it in a little UV cooker box. So you'd put in there in an ultraviolet light for about 20 minutes, and that would blank the chip. Then you take the chip, put it in your EEPROM program, and flash it. This is obviously quite time consuming. So if you were one of the rich kids, you could afford to buy an OLS 300, which was a product made by EVC that was a real-time emulator. So we would read the chip, We would then put the chip into OLS. We would then connect our emulator up, and using a specific cable, we'd then connect the emulator to the ECU. We would then bring the file that we'd read off of the chip into the emulator. Then you'd start the emulator up, and then you'd start the car. And what this allowed you to do was to actually real-time see the ECU running. You'd actually see the ECU running, and you'd see where it was accessing in there. And I can remember when I bought one, they were €2,500, and that's just like 2004, so quite a lot of money. But to actually see it running in real time was amazing, because you just like this whole remove blank flash, because we used to have, I still have them, like literally tubes, so you can't see that, but there's tubes of UV erasable chips.
I'm guessing the problem with that process, if you're not using the emulator, is if you want to make a change, you have to go through that 20-minute process of blanking the EEPROM, writing your change in, put it back into the ECU,
into the car,
run the car again, as opposed to the emulator. You can fine-tune everything, and as you say, in real time, and then once you're happy with the calibration, then do a final write into the EEPROM, correct?
You could, but what we used the emulator for more so was to locate where things were, because if you'd read the binary file out and you go, okay, back in an old Porsche, the wide open throttle enrichment was a 2x1 8-bit or 16, I think it was 8-bit line of code. So you've got, even though it was a small processor, a small memory, 256K, you still were looking for very small numbers. Rev limiters would be, probably two 16-bit values in a sea of numbers, and you had no idea where they were. So what you could do is bring the engine up onto rev limiter and look where it is and go, right, found you, there's the rev limiter.
So you fast track your learning on where it's actually accessing.
Yeah, and where it's at. And then what you would also start to learn is that the values that were associated with engine RPM in Bosch. So you'd go, okay, so I know 7,000 RPM is 25,000 and something. So that same value is stuck still today. That factor of, I think, 0.25 is still sticks with the RPM today. But that's how we used to find them, because there was no information available at all as to how to decompile an ECU. There was programmers like John Banks who would reverse engineer, but there was also guys like us that weren't computer engineers and so on. We would get an emulator and go, okay, so it's sitting here all the time. And then you'd start to move that and you'd watch what it was doing. So you'd have a PWIS, Porsche diagnostic tool, jammed in there, and you'd watch the runtime values. So you'd go, okay, let's move this. And I'd always move them down rather than up, because if it was timing, you wouldn't want to start adding 15% to an ignition timing value. But you could see, you go, that's timing.
Now, again, I don't want to sort of get too far ahead of ourselves, but what you just mentioned there with the rev limiter, and this really goes for everything, which might not be immediately obvious to those who haven't done this before. If you're looking at a timing map, you're not going to see numbers that would on face value make sense. You're not going to see 28 degrees, for example, are you?
No.
And that's where you've got these factors that you need to apply, like you mentioned, for your 7,000 RPM rev limiter. You're not going to see a physical number of 7,000, are you?
No.
So this is where the understanding becomes, there's another hurdle in there to get over, correct?
Yes, but basically what you would see is, depending on how you have OLS set up, is decimal, hexadecimal, or binary values. And that means you're just interpreting the number as it can be read as a binary number, a decimal, or a hexadecimal value. Generally, I always use hexadecimal values. So you're looking at a raw number. Now, the ECU doesn't care, because it's just processing numbers. It doesn't care about what that factor and offset is. But when the human calibrator has to tune the car for real, they need to see actual timing numbers and lambda numbers and ignition advance and camshaft advance. So the engineers who develop the ECUs work out what they call factors and offsets for the tables, and a lot of manufacturers will use different factor and offsets. So Siemens against Bosch against Delphi will all use different numbers, and Denso, and all these numbers generally are based around logical values. So they'll take a value of 8192. If you see a value of 8192 a lot, and you see that in HP tuners, you go maximum RPM value is 8192, or in a torque value it might be 255. So you know that what you're looking at in HP tuners tuners is actually an 8-bit table, because 255 is a maximum 8-bit value, and then you go 8192. I've seen that. And 8192, if you divide it by 81.92, you get 100. So that will give you generally your 0 to 100% throttle position, or it could be a multiplier if you divided it by 8192, and that gives you 1. But if you go to 4 decimal places, you'll find that 7,300 and something is actually 0.94. So it might be a divider, like a multiplier for turbo, wastegate, a multiplier for intake air temp. And once you start to get your head around looking at those numbers, it all just goes like Tetris magically falls into place, and it's quite a good experience, to be honest.
I mean, I've been through it with you training me on OLS myself, and yeah, absolutely, it's like a light bulb switches on, and you start seeing these common numbers like 8192 as you mentioned, and you straight away know in your mind, okay, I know what I'm doing with this. I know what the factor is going to be, or the scaling. So yeah, I just wanted to clarify that. Let's just get back to the read and write. So you've talked about the EEPROM, but I mean, this is an older generation of ECU where you physically needed to remove that chip. And I mean, again, I started, fortunately, a little beyond those years. I was probably on that crossover. But these days, I mean, fortunately, we don't have that, and we have other options for reading and writing. I mean, some of them are ultimately not a lot easier than that, but we can read through the OBD2 port, read and write through the OBD2 port in some instances. We can physically remove the ECU, and we can connect jumpers straight to the header plug and read and write that way. Or in some instances, we may need to actually physically open the ECU and read and write straight from the board. So talk to us about why those options exist, pros and cons of them, and what hardware is required.
I remember the EEPROM burner, and then the ECU evolved slightly then to an ECU that had what they call a surface-mounted memory device. So you had the processor, and then you had an external memory device, which is like an SOP44 usually, or some of them had little different square memory devices. The name evades me now, but eludes me. But the next tool I bought was a BDM100, again made by EVC, background debugging module, and you essentially would open like an ME9 ECU. So this is Mark 5 Golf sort of era. You'd remove the backing plate from the ECU, and there'd be a set of pads on there which you would have to bring a set of springs down onto, and that would then read the contents of the ECU for you in a very, very efficient way, because what we were reading beforehand was literally just the map data area. And obviously, as ECUs got a bit more technical, there was more information stored in different areas of the board. And I'm not talking about different areas of the map. Literally, the board contained sometimes 3 different memory areas. You'd have an EROM, like your immobilizer data, you would have processor data, and then you would have map data, and it would copy all this software into OLS, and then it would split them up into the different sections for you, which was a revelation then, because if you had an ECU crash, you now had the ability to recover it, because you had a mirror copy of the entire ECU, and as long as you could source another ECU, you could then copy it.
So that's different to doing an OBD2 read, where essentially we're only getting the calibration data correct, so you don't have that ability to recover the ECU from an OBD2 read?
No, and the thing is, OBD2 reads differ depending what tool you're using. Nowadays you have B-Flash, CMD, KES, Auto Tuner, PCM. There's like massive range of them, and they all do it differently. Like, so KES will give you a full read, PCM will give you a full read of a map data area, CMD, Auto Tuner, B-Flash protect their original files, because the original files are everything, by encrypting areas of the data outside of your map area. So a 2048 kilobyte read that you read from an ECU, like Ford Ranger for argument's sake, you can read with 5 different tools and you'll get 5 different files, but it's from the same car, and they're all different. But going back to when we had the BDM, the next thing that came out was the byte shooter, which changed the game completely. It was a kind of combination tool that allowed you to read data from the ECU on the bench in a kind of service mode without desoldering anything, and it was marvelous. And then it started allowing you to do OBD2 stuff and toolbox, which was just like, it was incredible what it would allow you to do and how quickly it allowed you to do it. And it was relatively trouble-free. It kind of went on, but the thing with them is they never had a subscription. They never had anything. They just was this guy in his house in back of Coblemore somewhere making this little blue box and selling it. Other companies came along then. CMD had been around for a while, and there was Alien Tech, and I then bought what was the next tool I bought? I think I bought a Freiling tool after that, and then I bought a Kess, and that again was another revelation where it would allow me to read a huge range of ECUs over the OBD2 port in relative safety, and very rarely did it crash. I think I have one of all of them, because I have to have them for what I do. But never have you been so spoiled now with tools and the ability and the range of cars they do and how quickly they get over modern ECUs. I remember when the BMW E90 came out, declared to the tuning world as untunable ECU, and I think the R35 came out as an untunable ECU, and I think it was done within 4 months.
Yeah, I've heard that more times than I care to remember, and the aftermarket, normally they always find a way. So just talking about that OBD2 read and write, because if for those listening who have come from a commercial reflashing background using HP tuners or Cobb or basically any of the name brands,
or something like that, yeah.
Yeah, that's the way we do it. So this is what becomes sort of a comforting, familiar place to be.
Natural, yeah.
We can't apply that across every vehicle, particularly modern ones. So we still may need to do a BDM read directly from the board in some instances. Is that right?
Yeah, so when you read an ECU, like for argument's sake, AMG, C63S, that ECU is not possible to read over OBD2. The functionality is not in the car. Cars, when they're built, are never designed to have their ECUs read, because the manufacturer knows by default what software is in them when they're born. So if the manufacturer were to bring up its version of your VIN number, it could tell you all the, I use a Porsche thing here, but all the Z values, the Z numbers, that it'll tell you what the interior is, what engine code it is, gearbox and so on, but it'll also tell you what software version that the engine and the gearbox and the ABS and heater control and everything else was born with. So reflashing a factory ECU from a manufacturer's point of view is not something they do that often. It's not that often that a manufacturer contacts you and says, your car's got to come in and be updated because we've found a glitch with the wipers or something. It just doesn't happen that often. So
unless you happen to own a Volkswagen during the Dieselgate period, correct?
Yes. We need to reduce your performance slightly. What was interesting with that was BMW then recalled a whole load of cars for a software fix, which was funny, but and Peugeot.
Suspiciously similar.
Yes. But the ECUs were never allowed to be read. So if you've got a Mercedes-Benz or an Amarok or something, how do you get the file? The file is identified over OBD2, and the software reads it and goes, okay, this file's 039G, whatever the software code is. It will then access a database within the tool's website, usually like Alien Tech or CMD or B-Flash. All of them have an online portal connected to the tool, which will then check that subversion of software, and it will locate that subversion of software and say, yep, we've got an original of that, and it will then download what's called a virtual file.
So you're not actually reading the file out of the ECU, you're starting with the stock file from that database. And I guess
from that tool supplier.
I guess that there's upsides and downsides with that. One nice aspect, which is important, is you're then starting from a stock unmodified calibration. So
you think?
Well, hopefully, but obviously the downside there is if you've already got a tuned ECU, you're not going to be reading that tuned file. So you're sort of starting from scratch.
No, you're going to flash straight over the top of it. Toyota's is a good instance. The only way you can read a Toyota, pre-2001, I think 2020, is to actually open the ECU and read them on a bench. It was great from a point of view as a tuner, because we knew that people would have to physically remove the ECU to copy our software, which is obviously extremely difficult on a Mercedes-Benz, because it's tucked deep in the engine bay. You've got to take half the car apart to get it out.
There's a few more barriers to entry in the way.
Yeah, well, manufacturers started doing that. They started making the ECUs extremely difficult. I mean, VW back in the Mark V Golfs, they came out with these security bolts, and the ECU was mounted up underneath the windscreen in a cage with these security bolts, very similar to the ones you use on the steering column. You know, the shear bolts.
You can do them up, but you can't undo them.
Well, you just used to snap the head off.
Yeah.
Yeah, just used to snap the head off. So, and the ECU was hidden underneath the windscreen in a cage, protected. So, to physically remove the ECU, if a car went back for warranty, all they do is pull the scuttle panel out and look underneath and go, "Cage is gone, warranty's void. See you later." You know, it just created lots of problems.
All right, we've got to the bottom of the different read methods, and the fact is, there's no one size fits all. We're going to potentially, depending on what type of vehicle you're tuning, you may have to use a different method of reading. So you've got the OLS software, you've got the interface to do that read and write. Now the other element, and it's irrespective of what you're reflashing, the other element that's really key to this whole process is a scanning or data logging software, so that you can physically see what the ECU is doing, maybe make a run on the dyno and then make a change, make another run. You can see what's happening with ignition timing, knock, etc. All of that stuff that allows us to then quantify our changes and decide on the next round of modifications. So does OLS provide a data logging solution, or is this through the third-party interface that we're using as well, like bFlash, CMD, whatever it may be?
When OLS first came out, there was no data logging of any description. In recent times, they brought out a device called a UCM 100, which was like a data logger of sorts that would allow you to log certain data, and then you could actually run that back within OLS. But it never really took off. I've always used either manufacturers' diagnostic scanners or VCDS, Rostec, HP tuners. Recently, there's another piece of software called ViaCal, which is incredibly good. There's a guy, I think he's Turkish, who wrote this piece of software at home, and it has created a logger that is industry standard now. You know, it's phenomenal what he's done. But whenever I try and teach somebody the tuning stuff, I said, like, the most important thing is to be able to know what the car was doing at the beginning and what the car was doing after you've made changes. You know, I stressed to the guy who works with me, Ben, you know, when he first started, I said, get a car on a dyno. First thing we do is read all the DTCs out of it, read any historical faults the car's got, and then we do at least 2 or 3 base runs with the car, logging its factory data. If you get a car come in and it's running 5-6 degrees of knock retard stock, you're like, either the car's been tuned, the car's got the wrong petrolant, or the car's got something wrong with it. We can't carry on.
Yeah, it's important stuff to find out before you try and put a band-aid over an existing problem that you may not be aware of. And I mean, I think that goes for, that's just a good, sensible starting point, regardless whether you're tuning factory or standalone ECUs. All right, so I guess we've one of the other questions that people are probably thinking right now is, okay, this OLS software that displays zeros and ones or hexadecimal, and we've got no pretty maps. We've got to actually figure out where they are and what they mean and which map's being used at any particular time, versus a commercial package such as HP Tuners has come up a couple of times. I'll use that, or the likes of Alien Tech, which in some instances that heavy lifting's done. There's a definition. You've got these maps. So why would we use OLS compared to one of these other commercial packages?
Well, HP Tuners is, and I know a few of the guys there, and HP Tuners is a great piece of software that allows you to see what they have found. And a lot of the time, what they have found is right. But every so often, people make mistakes, and or the stuff you want isn't there, or they don't support that particular vehicle, that software version platform. ECM Titanium is a great piece of software, but it's only as good as the guy that wrote the driver, and the driver in ECM is what turns the binary numbers into something you can actually see and define. So how I originally started working it out was, I did a lot of Porsches back then. So I had a 996 turbo, and I'd bought some software from Buchner actually, and I would open the original file, and then I would import the modified file. So now I could see the changes between the two files, and I'd start to identify the tables that he'd changed and trying to work out why he changed them and what they were. And that's how I kind of started. So I would look through, firstly, I'd go through and identify every single change within this file, because I knew this file, when I put it in the car, it worked. It made 1.1 bar of boost, the lambda was 0.81, there was no knock retard, and it made 60, 70 horsepower. So then I just had to work out what he'd done in order to achieve this. And then you would start to build like a map directory of different maps that would change. Some were big, some were single bytes. But what you would start to do is recognize this is charge pressure limitation. This is fuel was always a 16-bit value. Timing was always an 8-bit value, because timing doesn't need to go to a very big number. Timing needs to go from like minus 20 to plus 40 really would be the value you'd see. So that can be easily done in an 8-bit 0 to 255, whereas fuel would generally need to be a bigger number.
So the 8-bit versus 16-bit, essentially, we're talking about the resolution that we can get in an 8-bit versus a 16-bit number. And as you mentioned, timing is not a big number, so 8-bit's more than sufficient.
Yeah, so timing, you'd only really want one point of resolution, 25.2 or something like that. It doesn't need to go to 4 decimal places, whereas certainly lambda control, you'd want very high resolution in component protection maps, and like load tables is 16-bit high resolution. In a lot of Japanese, Chinese ECUs, Denzos, a lot of them run 32-bit. So you have huge resolution, but also the nice thing with 32-bit is generally the value you're looking at is the raw data value, because they've got so much room to play within the number. They don't have to apply any factors or offsets to the base number, because it's a raw value.
Let's just sort of put a nice little bow around this. So essentially, the advantage with OLS is you're master of your own destiny in terms of the calibration, or the definition, I really should say, roadmap of what addresses a fuel map, for example, the axes, the values. You're defining that from scratch, so you're master of your own destiny there. It's going to be as good or as bad as you define it. But the other flexibility here is you're not really locked down to, HP tuners, for example, don't cover maybe every car that you want to potentially tune, whereas with OLS, provided you've got the skill set to use it properly, you've really got no limitations, correct?
Truck, boat, car, lawnmower, forklift, marine applications, stationary generator engines, agricultural, anywhere where the engine has an ECU in it that can be read, you can, within reason, modify.
I just wanted to get that real clear. The other thing about the commercial software packages is that obviously they need to monetize what they're doing. So, for example, HP tuners will charge you a license to basically unlock an ECU and tune it, and the amount of money that's going to cost you is going to depend on what ECU it is. But every time,
and how advanced it is, yeah,
absolutely. But every time you tune one of that particular model of car, you're paying again. And as a commercial tuning shop, that's going to add up quite quickly, particularly if you're doing a lot of tuning. Whereas, no doubt, the entry cost to get set up with OLS and whatever your hardware interface is going to be pretty expensive. A lot of these interfaces are sort of in the vicinity of maybe €5,000, some more.
Yeah.
So there is an upfront cost, but for a commercial shop, that's usually very justifiable. But then your ongoing costs, particularly if you're specializing in one particular car, you've done all of your hard work and you've developed your calibration definition for that. From then on, there's no ongoing cost to tune more vehicles, is there?
None. So that's the question I get asked a lot. People say, "Oh, how much does it cost a car?" It's nothing. The software, you can do 200 cars a day with it. You can do 100 cars a year with it. It doesn't care. You can do as many as you want. The only cost you have generally is the subscription on your tooling. And I always sort of point people in the direction of tooling that has a subscription. And they go, why wouldn't I just buy this other, like AutoTune has no subscriptions? It's just historically, tools that don't have a subscription associated to them don't last that long, because once people have bought one, how do they earn revenue? How do they continue to develop their product without an income? Because there's only so many people.
Yeah, there's not going to be a lot of incentive to continue developing if you've made your money and there's no more coming in.
And that's it. And the tools that are fairly well developed all carry a subscription cost. I think OLS has recently introduced I think a €75 a year subscription for OLS 5 if you want to use some of their more advanced features where they have online scripting functions, which is developed with other tuning companies. So you could put a piece of software in and it would do a scripting function for you for certain features, whether they be emissions based or a lot of the time it can be for the readiness, CVN readiness calculator to check some verification number. A lot of countries now, when they do an annual test in the car, like your MOT, I think it's called in the UK, or certificate of roadworthiness, the CVN is checked by the Department of Transport. So the ECU is checked to see if it's been flashed. In some countries, it's illegal to do so. So they've developed a way to alter the checksum verification number so that when it's plugged in, it's fine. I mean, obviously, the guy doing the MOT drives the car down the road and goes, well, this has been tuned, but legally it's passed the test. So, and that's a plug-in tool that EVC have developed that will allow you to correct it.
Okay, that gets into some sort of very, very muddy waters now around emissions, which I'm going to park, and we won't dive further into that, because the difficulty as well is that this is very much dependent on whereabouts you're operating in the world. So I mean, all I can really say from this is understand your local requirements, and therefore it's up to you to make sure that you are keeping your car road legal. What is probably worth diving into is this checksum situation. You've brought up that term again, and this is a term that's thrown around quite a bit. If you're on any chip tuning forums, you've probably heard that term. I started out with a lack of understanding on this before I got into OLS training, but let's sort of dive into what is a checksum, why is it important, what needs to change with that checksum when we modify a calibration.
Okay, so originally, I'm not a computer engineer by any stretch of the imagination, but this is my understanding of how it developed and how it works. When they created the ECUs, there was always this worry of the data getting corrupted. People would go, oh, with a carburetor, if something corrupts, nobody dies. So manufacturers of the ECUs, Bosch and Delphi and Siemens and everybody else said, okay, what we'll do is we're going to run this check of sum, a calculation in the background. And what it does is it would go through an area, and it would have a start address area and an end address area, and it would sweep through and add up every single value between those two fixed points, and it would come up with the sum.
Mm-hmm.
The sum value, which it would then check against a number that it had in another spot. So it would say, go from here to here, add it all up, and it should come to this number, and then check. If it's not that number, something has happened to this data. This data has become compromised. And funny, when you have an emulator running in a car, I can remember talking with my friend David Alexander at Silverwater Automotive, and I said, I see this red wave go over the software. What the hell is that? He went, that's a checksum. That's a checksum running in the background, going over it and calculating. He said, just don't do anything while it's running, because it would add up. So that was the very simple checksum. This was basically used for data integrity. So if you change some values within those two fixed areas, you would then have to change the checksum value at the end. So if you made a number go up by X amount, you'd have to adjust the end value. So if you didn't, what would happen back on those ECUs, it would just hit the rev limit of $3,000. That would be because you had a cable throttle, it would be 3,000 RPM. And then when you got to electronic throttle cars, you'd on Volkswagens, for argument's sake, you get EPC light come on if the checksum was detected during the running. BMWs, I remember we used to see ROM emulation detection error, and a lot of the time Mercedes-Benz, that you switch ignition on and fans just stay on because it says checksum incorrect.
So essentially, the checksum was there for the manufacturer to ensure that the data was being received
intact.
The integrity of the data was correct. So it's a safety backup. But of course, where this comes unstuck is when we now want to actually change values within those addresses. Then obviously we're forcing that checksum to not add up anymore, so we have to correct the checksum.
We have to change the final value, and then manufacturers started using the checksum as a protection mechanism for tuners. So they started making it a far more technical calculation. I remember when MED 17 came out, if you ran when the checksum came out with OLS, they specified a minimum computer basics. And I think the very first version of it, you had to have a NVIDIA graphics card with a CUDA cells, whatever it was called, in it, because it was so computationally extensive that it almost stopped the computer in its tracks. I mean, people who use certain Italian products will know when they did the hit the checksum routine on the little portable devices, you can't do anything with your computer for probably 3 minutes while it's calculating the checksum. So what became a mechanism for protecting the integrity of the data in case of data corruption on old types of memory has now become a very sophisticated way to stop us programming the ECUs. And I mean, you'll hear all different things like the RSA this and the seed encryption that, and God knows, and they're becoming extremely technical now. Luckily now, most of the tools will run checksum correction for you, and that's the difference between people who buy the copied tools. So the checksum corrections don't necessarily always work correctly or properly because they rely sometimes on an online connection to get the latest workaround for that correction, which is very present now in the latest generation MG-MD1 ECUs, because they've obviously Bosch have learned how they're getting backdoored, and it's an ongoing battle. But from the reverse engineer guys at CMD and Byte Shooter and B Flash and Auto Tuner and Kess and so on, to the engineers at Siemens and Bosch, and it's almost like I see your challenge and I accept your challenge, and you can just imagine the guys.
Essentially, though, as far as we are concerned in the aftermarket, this checksum correction, it's important. It needs to be done. We're not out there with a calculator physically adding up values and changing a checksum. This is done.
No.
You're going to essentially want a tool that has this built-in checksum correction. So it's automated, it's done for you. It's something we need to understand is there, but physically it's being done in the background, so we shouldn't need to worry about it. That's really the long and the short of it.
The end of it, yeah. But if you're running a checksum correction within OLS, sometimes you need to run a checksum calculation if you've got a damaged file you're repairing for somebody. And OLS, when you go to export the file, it doesn't actively correct the checksum on the fly. It will do it on the export of the file from the software. So if you have active checksums running, what it will do is it will say at the very end, do you wish to correct the checksums? If so, click yes, and it will correct the checksum and export the file as a different version to the one you've just tuned. So you might have Andre's version 7 final, and then it will say, do you wish to save the other one? You'll say Andre's version final 7 _ CS, like checksummed. So that if you've got a guy with a different tool, you can send him a file with either the checksum to be done externally, because what you mustn't ever do is multiple the checksums, because different tool people and different software use different ways of modifying the checksum. Ford Rangers, when you do them with HP tuners or when you do them with a Kess, the checksums are different, and it doesn't work because bad things happen.
All right, let's dive a little deeper into OLS itself, and I think we've already got a bit of an understanding out into this podcast now that we're left to our own devices in terms of interpreting whereabouts in the raw binary file our maps are. We've got to find them, we've got to define them, add the scaling, find the axes, and then scale the axes so that we can actually display them in what makes sense as a conventional map. There's another element to this which is an aside in terms of we also need to really understand how that particular ECU family operates in terms of their
logic flow.
Yeah, logic flow, exactly. Not every ECU operates the same way, but that's an aside for the moment. Now, we're doing this with pattern recognition, and I guess first of all, when you open a binary file in OLS, it will actually go through and find what it thinks are maps, which can be helpful or can be complete garbage. So tell us about that. Can we rely on that? How useful is that function in OLS?
Well, that function has been evolving over the last few years at a rapid rate, because recently, for 2015, I suppose, you suddenly had access to Toyota ECUs, and they had an axis which I'd never seen before, which was Denso vertical axis. So previously to this, I'm familiar with very much with Bosch, and you would have a table, say for the argument's sake, the table's 16 by 16. How this would be defined is there would be two characters in front of the axis, and in hexadecimal it would be 16 and then another 16 which told you the next two lines. One was 16 down, which would be your y-axis, and then another one was 16 across, would be your x-axis, and at the end of that would then be the table. Or you might have a 8 by 4 or a 6 by thing, but with Denso it had a vertical axis. So if the map was say 20 by 21, the actual data for the y-axis was in front of the Z value. It was a really strange. I'd never seen it before, and OLS didn't recognize it in any way. With recent updates, it now recognizes Denso vertical, and if you go into the map recognition software setup, you can actually now ask it to identify very specific types of maps. But once it starts learning them, it actually gets better at doing them. But with map recognition, it's a very difficult thing to teach. I was working with some guys a little while ago, and the discussion of 2D and text came up, because in OLS you can view the binary data in text view, which means you literally just see the numbers on the screen, and then to the right of them you'll have a bar value, which is a graphical representation of the numerical value in a bar. So you just see like little segments, a bit like an old graphic equalizer from the 80s, those are the little bumpy bumps. And if you then go to 2D, what happens is you look at the numbers on their side. So you don't see the numbers as a value, you see the numbers as a spike, and depending on what scale you've got, you'll then start to see three-dimensional or two-dimensional patterns, that start to form. And if you were to look at a file, we go back to the original Porsche that I sat and copied all the data from one to the other and went, right, what's he done here? What I could do with that is, when it was in two-dimensional form, I could then see the shape of the maps he'd changed. And then when I got another one in, I could find those same maps based on the physical shape of them.
So it's pattern recognition. You start to learn as you do more of this that, for example, a driver's wish map looks a certain way.
Yes.
So when you see that shape, you're straight away, yeah, I know what that is. And same with EGR, boost, whatever it might be.
Yeah, and the more you do it, the quicker you get at it. And I sit and do it for people literally every single day. And some guys who are extremely proficient tuners, they'll ask me, can you just jump on my computer and just define this? I'm doing this Range Rover diesel and I just need the following maps. And I just jump on and go, right, and plow through it in about 6 minutes. And guys would go, I feel a bit sick. How do you do that so fast? I said, well, I do it every day, and it's burned into my brain. It's like guys who use Motex all day long, or if you watch, I'm trying to think of his name, the guy from Rice Racing, if you watch him on a live ECU, it make you feel sick how fast he flies through it. Or if you watched you on a Motec, I'd just be like, whoa, what did you just do there? How did you just find that? Like,
it's just whatever we become familiar with and proficient, and it is one of those things that getting good at any of this, and OLS particularly, is going to take a lot of repetition, a lot of time. So coming back to the maps that OLS is physically finding, so some of these will be useful and help guide us. Some of them, it might miss maps that we actually do need, so you've still physically got to look yourself. And then maybe it's got some that it thinks are a map and maybe it's missed something or it's got it wrong. Is that sort of a fair interpretation?
Yeah, a lot of the time you'll see it. You'll have maps within maps, and a giveaway to it will be like in Bosch. You'll sometimes see it will say Phoenix. And Phoenix is an agricultural ECU. So a lot of the time you go in and say, okay, switch off Phoenix recognition, you don't need it. Or Visteon, like Visteon is a processor used by Ford in the Falcon, in Aston Martins, in some Siemens ECUs it's used. It's a proprietary map layout specific to a processor. So you just switch that off because you're in a Bosch ECU. Or if you open a gearbox file, you'll say, I want you to specifically log Temic ECUs or a particular type, and it can be a bit overwhelming when you see it. I found 14,000 maps, and you're just like, I need 12 of those really to do my job. And I always sort of say to people, once you've identified the maps that you're using, go down to the potential maps and delete them all, because you can always research them, but when you're using the OLS, switch the ones that you no longer need off, because then it's just a lot easier to hop between them.
I think you've just highlighted something that's really worth pointing out in a bit more detail as well. So when we're dealing with an aftermarket ECU, we've got a relatively limited number of maps that we need to deal with. I mean, most of your tuning is probably going to be done on just 2 maps. It'll be the fuel map and the ignition map. And the other 100 or so parameters, once the ECU is set up, we don't touch. Factory ECUs are even more complicated because there might be literally thousands of either individual parameters or maps. And again, we probably only need a handful of those. So when we're using commercial software, we keep coming back to HP tuners. We'll use that again. They've identified the main maps that we're going to need access to, and have ignored the few hundred other ones that we don't. But when we've got OLS, we can see everything, and that can be overwhelming.
A lot of the time you get these people will, when they first start using OLS, they say to me like, oh, I need a demos and I need an A2L file and I need this. And I was like, a lot of the time I'll be online with them. I go, okay, I'm going to open an A2L or a demos file for you now, and you get a sick bag ready, because it's not what you think it is. This is the manufacturer's factory calibration for this ECU, and this includes everything, every single mathematical calculation and logic that is used for this ECU, from the time it starts to where it saves the crank position sensor to its emission controls, everything. And if you open, I don't know, say for argument's sake, a CMOS 18 in a Mark 7 Golf, I think there'd be like 37,000 maps in a description, like a proper A2L matching hex file.
Let's just talk about those terms. I mean, you've just given us a bit of an idea, but you've used the term A2L and DAMOS, and we're going to hear those again used all the time on chip tuning forums. So can you give us a dummy's guide to what those terms actually mean?
So in my understanding is when you have a manufacturer who actually sets a car up for calibration, they'll use a development ECU, which is generally like the factory control unit, except what it has is a sandwich plate in between the processor and the board, usually made by, there's a few different companies, Vector, Inca, ACIA, I think they are. And in doing so, what you have to have is try and describe it. Imagine looking at a map of New Zealand. So you've just got this map and it just shows you the countryside. That's your hex file. And then your A2L is what you import into your map software that suddenly lays out all the roads and all the towns and where all the side roads are and where the pub is and where the bottle shop is and where the supermarket is. That's sort of how they work. So when the guy who's calibrating the latest Ford Ranger goes out to do his development on the road, he will have the hex file loaded in, and then he'll import the matching A2L file, which then populates all of the data. If you ever used a Bosch Motorsport ECU, they use exactly the same data. So the Bosch Motorsport ECU is essentially a development ECU with an open user application, and they use A2L and hex files, although they call them slightly different things. And that's how you would actually calibrate the car. I mean, the car would be done essentially in a software environment to start with. I think BMW, when they developed the GS 1200, they developed the entire engine runtime within a software environment, and the motorbike was started and run from a computer generated file. Like this will start and run the motorbike. And to my understanding, a lot of the calibration now is specifically for guys to get round manufacturers who want to use more cost effective components in an engine to achieve an end result with emissions. So that's where the A2L and the hex file comes from. So when you get an A2L and a hex file, it might be of use to you, but unless it's exactly matching the file you have, it's a waste of time, because it can be, the offsets can be different, and every software version is different. So if you get Mark 7 Golf, for argument's sake, there's, I think in this country we've got about 12 or 14 software variants, and each one is different. Essentially some of the big tables are all the same, but there's lots of small finicky stuff that is completely different, and you need a description for every single version. You can't grab one, but you can make, I think I did it with you, we could make a really good map pack for just about any EDC 16 file based on one EDC 16 description file because the manufacturers didn't diversify.
Let's just park that again for a moment, because there's a bunch of stuff I kind of wanted to unpack in this. So I think we've got a good understanding of the A2L file and its relevance or potentially lack thereof, particularly in terms of giving us a huge, overwhelming amount of information that we don't need. On the other hand, you've just mentioned the term map pack, which I think is probably more useful. We'll dive into that. So A2L versus a DAMOS file. Can you give us a bit of a breakdown on where the differences there are?
The DAMOS file is the creation within OLS, from my understanding of it, is once you've created the DAMOS file, you can then read it within. I mean, OLS will import an A2L and a hex, so you need to have the matching S19 or hex file and the matching A2L file to create a DAMOS.
Mm-hmm. Okay.
So that the one is the result of the others. And then once you have that, then you have a description. But I always find for guys, say for argument's sake, they're doing a big turbo conversion on a Ranger, or a big turbos on a Mercedes Benz, or anything where you're going to be slightly out of factory stuff. You say to them, what I can do for you is I'll create you a map pack which will identify everything that I feel you need to do this work with, and it won't be so overwhelming. So instead of having to troll through hundreds and hundreds and hundreds of different things, all we've done is we've given you everything that needs changing and identified it for you. And that's obviously a service that I provide and we do as a living. But if you open up a gearbox file, like a DQ250, there's thousands of things in there. But if you said to someone, look, there's a stage 3 file and there's a stage 3 map pack, so essentially everything that's within that file is marked, so you know exactly what we've changed, and you can go through yourself and go, well, I can do better, or I want to change this. And the same with an engine file. It's like creating a file within ECU Flash and then giving it to the customer and saying that the tree on the left-hand side, all you're going to see is the stuff that I've changed. You don't need to see any of the other cold start and this and that and all the other stuff.
So it dumbs it down to the essentials, removing kind of all of the noise and improving that sort of signal to noise ratio.
Yeah.
I guess then, just from what you've mentioned there, and we haven't even talked about your business, the file service, which I'll dive into in a moment. So there's multiple ways of working with OLS. Either you put in the hard yards and learn how to find and define those maps from scratch by yourself. And I'm going to guess there's probably a relatively, because it is a specialized skill and it takes time, I'm guessing there's a relatively limited number of people that use it to do that, compared to those who will work with a company like the file service and buy either a off-the-shelf calibration that's ready to just basically flash into the car and call it good. So a stage 2, stage 3 file, whatever that might be. And then there's the other way of working with that is a map pack and the stage 2 upgrade file. And then, as you say, they can see what you've changed. They've got the map pack, it's defined. They don't have to find the maps that they need to change. That's already done, that heavy lifting's done. Then they can use it kind of like any other commercial tuning software to make the changes. Is that kind of a reasonably good sort of way of breaking that down?
Yeah, I think what you'll find, you'll get guys like, say, yourself, who are competent in what they do, and they just need the layout. They just want a starting point, but they're quite proficient if they know what the bits they're looking at. But also there's a bit within them that just says, I know I can be a bit better than this, or I can change it a little bit, or, well, yeah, but that's the best bit. That when I sort of teach people, I really want them to evolve into being somebody that can do it from the beginning to the end and go, I beat the old boy, or yeah, it's great. I mean, I've had guys that can't beat me for years, and then they'll send me a dyno sheet and go, I got you, old man. They're like, fantastic, well done. I said, at least you had a car there, I didn't.
Yeah. I mean, I think what's important to mention there is, when you're providing an off-the-shelf map, you're not
There's
necessarily...
compromises in it.
Compromises, exactly. You're not going to have the exact car in front of you on a dyno. And maybe it's got a slightly different exhaust system. Maybe it's got a different air filter. Maybe, as you say, the air temperature is different. So you've got to compromise. You're not going to be pushing for that last kilowatt because, for all you know, that's going to be beyond the edge. So that's when you get that base staged upgrade file. And yeah, there's almost certainly the potential to customize and tweak that on the dyno for the exact car and conditions it's been running in, and make a little bit more power. And as you say, beat the old man, maybe, if that's a sticking point for you.
Yeah, we did exactly that with a car. I think I showed you, and I said this is a base file, but if you were to tweak these following tables, you could probably get another 5 or 6 kilowatts out of it if you wanted to. And I sort of give guys that opportunity, and I say, like, this is where you need to look, and if you want to optimize it for your fuel, your area, these are the bits you need to change, because I'm not going to sell you something that's 10/10ths without doing extreme data logging and very time consuming. What I'm going to do is I'm going to give you something that's 7 out of 10, but I'm also going to give you the directions to the other 3. And then that's up to you to learn. But what I've done there is I've saved them the 15 or 20 hours needed to get to that point, which is, as a commercial workshop, that's a great...
Time's money.
Yeah, time is money, and if you can achieve 7 out of 10 on your first crack for your time for your customer, you're going to get a better end product. And also, it tries to develop curiosity out of people. That's why we do this. That's why we go and do dumb things we shouldn't have done. We take on cars we probably shouldn't have, because we're curious to see if we can do it, if we can beat the old bloke, or if we can get better. See if I can. I always had a thing in my head where I had a couple of European tuners that were very good with Mercedes-Benz, and I would get close. I'd like, how is he getting that last 15 kilowatts? Like, we're talking of, say, a C63, where I could go from 310 to 360, and this particular guy, he'd get another 12 kilowatts. And I'm looking again, how are you doing this? And rather than throwing my hands up and walk away, I'd go, right, Ben and I would sit here and we'd spend hours and hours working out, and then finally we'd get it. Like, I know what he's doing. Go in, try it, and go, boom, got you. I won't sell that got you bit. That's the bit you've got to...
You got to do the work yourself.
Yeah,
at some
I'll
point.
show you, but there's no point in me just giving you the complete final solution, because then you'll never learn. You'll never learn that bit that makes you the difference between one workshop and another.
Let's talk in a little bit more detail about what the file service is and what services you offer. So yeah, give us the high level view.
So the file service I started probably 7 years ago, because I realized there was a lot of people who had bought into this master-slave kind of thing, which I don't really personally agree with. So all the tools that we've mentioned, apart from HP tuners, I think, all the European tools come with a master or a slave. So what would happen years ago, you'd have one master tuner with a master tool, and then a slave would read the car, the file was encrypted, he would send that to the master tuner, he would then make changes as he saw fit and to his country's specifics, and then he would send the file to you, and you'd flash it in the car, and away you go. A majority of the time, nobody ever did any data logging, anything. But a lot of the time, because where we live, all these file services are in Europe. So if you put your car into a company and they said, oh, we need your car overnight to do the tune because we want to check the cold start routine and all this, it's like, no, you don't. What you're doing is that's getting done in Europe. And the guy who's doing it, or the lady who's doing it, is not awake till 5:30 that night. So your car's getting done tonight by Helmut in Germany, and it will be done at 8 o'clock this evening. So I thought, do you know what? I can do this here. So what I started a company that I probably had about 10 or 12 guys. I said to them, look, I'm prepared to offer you an Australian timed service where I would create the file within a 90-minute window from scratch. And if I hadn't done one on my dyno, we would do it together on yours. So it'd be the same charge, but essentially I would do it live on your dyno with you, And the beauty of it was they got the original file and they got the tuned file, but in a master version. So they got the original and they got the result.
So just coming back to that master-slave arrangement, as I understand it, the slave really is completely locked out of doing anything. So they're reliant on that master tuner. So if they run the thing with the new calibration that the master tuner sent them and they decide they want a little bit less boost at 7,000 RPM or whatever that may be, then that's another back and forth with the master tuner.
And a lot of the time that the tunes were based out of Europe or America, where the petrol is way better. If you get a piece of software out of Germany or Netherlands or the UK for a modern petrol car, they will have put ignition timing in it because they've got good fuel, and most of the time their ambient air temperatures are much lower than ours. So you've got a Mercedes-Benz that's tuned in Netherlands, where the ambient temperature is like 12 degrees and the fuel's like 102 RON. It's going to be no good here. Well, you know yourself, in New Zealand, you get a nice hot day with poor fuel, it's gonna ping its brains out.
Yeah, I think I can't say enough about the importance of tuning for the specifics, as opposed to relying on some generic tune that, as you say, completely different conditions. So you've kind of alluded to there that you can do this basically from starting from zero in a 90-minute window, which is pretty impressive given how slow I am at it with my level of knowledge. I'm guessing though that over time, the 7 years or so you've said since you started the file service, you're building up this sort of library of
big database,
maps, map packs, calibration, so it kind of gets easier for you. I'm guessing once you've done one, you can sell that over and over again.
You can, but also one of the things I've introduced to every single master dealer I've got is that I tell them how that works. Like, for argument's sake, if you have nobody ever tells you this, but once you have all the software versions, you don't need to tune them again. So if you identify a piece of software in a car and you go, okay, this software variant is a 60p92, you don't need to read the file out and create a file. You just go into OLS, you type in 60p92 or whatever, 2559J, and search. Got you. Export, write to car, done. And nobody will tell you that. That's what I would say. I at one stage I had about 130 users, and of those 130, probably 120 were slaves. So when I sell people a slave tool, whether it be CMD or a KES or whatever, I would give them an open agreement. So that means if you wanted to change your tool from a slave to a master, you didn't have to contact me. A lot of the people who've bought slave tools over the years can't get them unlocked. So essentially they've got a very expensive doorstop. So they've got this situation where they fell out of love with the guy, or they want to progress with their learning, and the master's gone, I don't really care. You're staying with me, and that's the end of that, and I'm not unlocking your tool. I changed radically how I did things. That I said that you get an open letter of release from the file service. If you slave a tool to me, say for argument's sake, you said, look, I want to get into this tuning game, I would essentially start you on a tool that matches what I think would suit your criteria. So if you were going to do a lot of German cars, this is the tool I would send you. If you can do a lot of Asian stuff, this is the tool I'd advise. Start with the slave, because the entry costing is much cheaper. The files, you still get to keep them. You do whatever you want with them. Once you've learned how to read the car, how to save the car, how to fix the car when it stuffs up, how to get around all the little nuances of this industry, when you're ready, we then switch you to master, which it doesn't bother me, because as far as I'm concerned, you'll still use me because you need me to save you time. That's what I'm here to do. I'm not here to trap you into a master and slave relationship. I'm here to teach you how to use the software. I'm here to learn. I've got 40 plus years in my brain that I want to share. That's what I want to do.
Yeah, and that sounds like a much smarter arrangement, rather than, as you say, having an expensive doorstop and getting these slave dealers offside and angry about the situation they're locked into. In terms of, I guess it's going to depend on the specifics of the tool, but what are we talking in terms of a difference between a slave and a master? Is it double the price?
Twice the price usually.
Okay.
Yeah, so it depends on a CMD. Like, I think a CMD, a master's, is it €8,500, Ben? About 13,000 Australian at the moment for a master CMD. I think a slave's about 6. But they're the same tool.
On that note, which is probably also worth just discussing, what we've talked about so far, the numbers are out of the ballpark of our average enthusiast at home who's got a late model Audi or Volkswagen or whatever it might be that they want to
A
tune.
hobbyist guy, yeah.
I mean, no one's going to go and buy a $13,000 tool plus a license for OLS just to tune their car. That makes no sense. What are their options there? Is it simply to go to one of your slave dealers or something of the like?
I think when anybody goes to get a car tuned, they've got to look at the enthusiasm and the background of the company that they're dealing with. Like, if you've got a Subaru, you don't walk into a garage that's full of Golfs. You go into a guy that's got some passion with that brand. If you've only got one car to tune, sometimes I've had guys who've got an interest in computers and so on. You go to them, like, if you're just going to tune this car, there is other products that are far more accessible, but they're not as easy to use. So there's companies like PCM Flash and MMC and all sorts that sell little tiny dongles. And unfortunately, the thing that's happening in Europe has created a bit of a problem with being able to get hold of them. But they're a really great way to read and write your car on a very low budget.
Okay, so we don't have to be spending, for the average enthusiast, we don't have to be sort of coughing up €8,000 for our entry price.
No.
There's cheaper options.
I think entry-level PCM Flash in euros, the basic dongle cost is €35. And then if you wanted like the module for, I don't know, MED 17, it's probably about €270. And that's yours forever.
Okay. Yeah, that's starting to sound a little bit more reasonable for a one-off.
And that's what I've done. I've got workshops who are in the middle of central Queensland. There's no point in them owning a CMD. They're going to see one German car a month. So I look at what are the last 20 cars you've been asked to tune. Let's base your tool purchase on what you're actually going to make money out of, and let's base your training around. There's no point in me teaching you how C63S operating system works, because you're never going to see one. You need to know how a Toyota works or a Nissan works or an Isuzu works. There's no point in me showing you how an Isuzu truck works, because you're like, I don't even want to go in one, let alone tune one. But I'm really interested to know how MED 9 works or EDC 17 works or something, because they're all different. And that's what I've tried to do. I've had a couple of people from different companies who've said to me they're not particularly happy with what I'm doing, because you're showing people the last secrets. I said, yeah, but do you not think it's about time that it was these secrets were given out? You've got companies that are making millions of dollars selling you the same file again and again and again, and I just sort of went, I don't want to be a part of that anymore. That's not what I want to do.
We struck the same sort of attitude when we started selling tuning courses for aftermarket ECUs. I mean, there's a portion of the tuning industry, and fortunately, I think it's the minority who kind of want to keep all of this information locked down and keep it shrouded in secrecy and mystery. And to me, coming from a 13-year background of tuning cars and seeing the workmanship from other tuning shops all around the world, that lack of information was leading to terrible results. And what that does is it pisses off the end user who's paying good money to have their car tuned. And what that in turn does is it leads to the whole industry getting a bit of a checkered reputation. So I wanted to improve that level of knowledge. And I think when we do that, everyone wins. I mean, I think there's enough work out there to go around as well. So, it sounds like there's that same scenario happening in the OLS world as well.
Yeah, I get an enthusiasm for teaching people, and I love it when people get it, that the penny drops. I did a guy in Toowoomba who tunes motorbikes, and I showed him the relationship between the binary values and the things, and he just got it straight away, and he was so happy because he just went, oh, now I know how all this works. And it was like, yeah, it was it was a great feeling of like, a result. And yourself, when you've opened a file out of a car and you've looked into it and you've just gone, you shake your head and you think, this person has paid somebody a lot of money, to do this to their car. And you think a car is usually the second or third largest sort of thing you'll buy in your life, out past your house or your caravan or some other stuff. It's an expensive thing, and you're entrusting these people with your car, and you have no idea what they're doing, and there's no qualification for it. Like if you want to be a mechanic, you have to take there's this place you have to go. If you want to be a plumber, you got to do an apprenticeship. You want to be a tuner, you need a laptop.
Buy a dyno and you're good to go.
And we don't even need a dyno.
No.
You
Well,
need
these
a good
days,
car
a
park.
lot of them don't.
Good car park and a power supply and a mobile phone. And that's the bit that scares me when people go, oh, I can get my car tuned for $400. I'm like, good luck.
All right, let's talk a little bit about the future of tuning factory ECUs before we finish up. And, obviously the manufacturers probably aren't overly interested in the aftermarket industry making modifications to their latest pride and joy. And we've sort of already talked broadly about some of the challenges that have come up and then been surpassed by the aftermarket. In your opinion, is there always going to be a way to tune these newer generations of processors that are coming out, or is it just getting increasingly difficult? Is there the potential that we will see these truly untunable cars rolling off the showroom floor in the future?
I think eventually it possibly will happen, and I think it will be down more forced by environmental protection agencies than the manufacturer themselves, because I think sometimes it's in a manufacturer's interest for there to be a cult following of a vehicle for it to sell plenty of them. The manufacturer didn't create the WRX and lock the ECU out of it and lock everything out of it and make it completely impossible to tune, because they knew 60% of those cars were going to get modified. Volkswagen created this Golf R that just when it came out in its Mark 6 form, I struggle to see one now that's not been tuned. Manufacturers seem to come out with platforms. You look at the RS3, that has become the tuner platform car to the degree you've got people developing complete custom operating systems for it, engines, CNC bits. It's created a huge follow-on, and I think manufacturers they create them, but they know it can be done, but they make it exceptionally difficult, because what one man creates, another man can uncreate. There's always, if a brain's worked out how to do it, there's another brain somewhere that will work it out to backdoor it. The problem being is when the backdoor solution is released too early, that's when the problem arises, because then the manufacturer has to be seen to close it. So you've got a situation at the moment where there's an ECU in the Mark 8s that can be tuned, but manufacturers of the tools aren't releasing the solution openly, because what they don't want to do is the manufacturer who owns one of these tools to run the routine and go, right, that's how they're doing it, which is what happened probably 3 years ago with the initial MG1 release, which was the new generation ECU, petrol ECU in 2018-19 on. One of the companies released the solution. They just came out and bang, we've now released this solution, much to the dismay of everybody else who writes the hardware, because they just said, we all know how to do this. We didn't release this solution because the ECU is still in production, and all that's going to happen is Bosch are going to work out what you've done and they're going to close that door, which they did, and that's in the new incarnation of ECU. They said these are now locked. You can't tune them. Like, see you later, it's done.
So there's a balancing act that the aftermarket has to sort of weigh up there.
We have to wait. We have to wait carefully, and even the ones that they now have locked, you can get them done. There is companies already that now have a solution, but they won't sell you the solution to use in your commercial tool. You have to send the ECU to them. They'll perform the unlock, and then they send you the ECU back, and you can then tune it. So I think as long as there's people who want to make cars go, there's going to be people who want to sell you a solution to do it.
I mean, ultimately, there's a lot of money to be made in the aftermarket industry, so these companies are massively incentivized to find ways around whatever these OEs are throwing up as roadblocks in our path. So I kind of back the aftermarket to find a way around it. Maybe it'll take a little bit of time in some instances.
But it's always been that way, that people want to, modify something. They get something that's really nice, and they just want to change it. I think software and hardware companies have built huge businesses behind this, so to them it's very important that it happens. If you look at how much money's been spent in reverse engineering ECUs through ECU Tech and Cobb and HP tuners, that's three big players there. APR, ATB, all these Oettinger, and they're big players in this industry, and they're not just going to suddenly go, oh, well, we can't do it anymore, see you later. They're going to want to continue on
Definitely.
with the business until manufacturers make cars that won't be as interesting to tune. I understand there's going to be a progression into electric vehicles, but I can't see how overrun burbles on a Tesla is going to be much fun.
Might be a bit more tricky to tune in. Yeah. I mean, that's a whole different can of worms. And I mean, like it or not, that day is coming. But
that's coming.
We digress. All right, look, James, I think we'll move towards finishing this thing off. We've gone pretty long here, and we do want to respect your time. So we've got the same three questions we like to ask all of our guests at the end. The first of those is, what's next for you in the future, for you personally and for the file service? Any sort of new directions on your radar?
I'm going to try and attend the trade show next year in Melbourne to try and get it out to people that there is somebody there that will teach you one-on-one. I don't have any wish to teach rooms full of people. I much prefer to do a one-on-one thing. I'm not out there to make zillions of dollars out of it. I realize I have a time. When you get to a certain age, you suddenly realize you have a timeline, and it becomes quite apparent, and there's a lot of stuff I've still got in my head I want to share. So that's what I want to do, and hopefully develop that part of the business more so, and help people with their tuning careers, whether it be this is how you use HP Tuner's scanner properly and to get the best out of it, or this is how you get B-Flash to log properly, and this is what all this data means, or introducing people into new technologies like ViaCal on where live tune a factory ECU, and people didn't even know it existed. I suppose that's where I kind of see the next 5-8 years of my life. I mean, by then I'll be 65. It's then I'll hang my laptop up.
Kick back on the beach with a margarita, maybe.
That's it, hopefully.
All right, next question. Is there any advice you'd give to a younger version of yourself, or, for that matter, our followers who are listening, to help fast track your career, maybe avoid some of the pitfalls or mistakes you may have made along that career?
Always use an original file. I suppose do your research on what your market is, and don't try and be everything to everyone. Try and choose something that you can be good at that suits your demographic. If you're living in central Sydney, don't specialize in 79 series Land Cruisers. Pick your battles with what you want to learn, because you can't learn everything at once. You have to progress and start with the basic stuff. So many people go, I'm going to go and buy a C63 and become the biggest thing. I said, no, go and buy a 316i BMW and learn how to do it. And buying everything doesn't mean you can do everything. It just do few things, but do them really, really well. And that's how you get better than other people.
Yeah, that's really good advice. I think that goes for the standalone world as well. Yeah, if you know one particular product inside and out, you're obviously going to be better at it. And I mean, particularly if you are doing this as a business, as we've already mentioned during this interview, time is money. So if you can do a calibration in half the time, you're going to be able to do twice the number of cars. And obviously, the math's pretty straightforward there.
And a better quality product for the end user,
Absolutely.
Be known for being very good.
I'll relate that back to my old business, where we sort of initially probably based everything around or focused on the Japanese domestic market models. We're always known for our Mitsubishi Evos due to my own drag car, but we did a lot of Subaru WRX and STI as well. And there's so many generations of those cars, and they come in and everything was different. And it was difficult to, A, quote accurately because you didn't know what you were going to find. B, you couldn't give a definitive answer on what it was going to make because, again, the combination of parts was always different. And what we did later in that business is we actually kind of pivoted a little bit, and we focused on the Australian domestic market, Holden and Commodore, Holden HSV Commodore market, which is essentially for US is the LS. And those cars, we literally had a package of parts. So it was an exhaust, an intake, headers, and we'd put those on. my guys in the workshop knew what they were doing. They could do it quickly, repetitively, and we could tell within 1 kilowatt essentially what that car was going to make on the dyno. And the odd time it didn't make what it should, you knew that the guy had the wrong fuel in it because it was pinging its head off. And that was a very, you always had happy customers. The results were always great. So I think, if you can focus on a particular market, maybe a handful of key cars.
Just get good at something. Yeah. If you're going to do Volkswagens, learn one. I mean, here we do Golf Rs. We do hundreds of them, literally hundreds of them, and we know them inside out and upside down. And to anybody that comes, I want to be a tuner. All right, so what do you want to tune? Everything. You can't do everything. You need to pick. We're only going around and saying the same thing, but you just need to pick something and stick to that and get really good at that, and then
the next thing,
move on a little bit, and sometimes listen to other people that have done it before.
No, solid advice. All right, last question for today, James. If people want to follow you and see what you're up to, maybe get in touch with your business, how are they best to do so? You've got a website, social media account?
I'm a dinosaur with social media, unfortunately. I have a website, www.thefileservice.com.au, and I think there is a Facebook page, which I should really update every so often, but I spend most of my time on the phone to people every day. So it's interesting because most people find me after they found everybody else, and they've done all the courses with all these other companies and spent heaps of money, and then they go, I have a 10-minute conversation with you on the phone and you've just fixed everything in 10 minutes. And I said, yeah, that's usually the way it goes. But yeah, www.thefileservice.com.au, and my phone number's on there. You just ring it. And I don't do Instagram, and I don't do all the other stuff because I'm too busy actually doing work.
Well, we'll link to your website in the show notes as well to make it super easy to find. Hopefully your phone doesn't continue to ring off the hook on the basis of this podcast, and you can actually still get some work done. Great to chat with you, James. Thanks heaps for your time today, and we wish you all the best for the future.
Absolute pleasure. Thank you very much. Have a lovely day.
If you enjoyed this episode of Tuned In with James O'Connor, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high-quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt anywhere in the world. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to, and it's a bit of a mouthful, Bean Boy Biggie Tupac from New Zealand, who has said a great podcast to listen to if you want to understand more of what goes on inside the world of tuning, engine building, and so on. He's also asked, hey Andre, if you see this, I do have a question. Are you guys looking into doing a video release of the podcast at all? It would be awesome to have some visual as well. And also, you guys should sell some HPA stickers. Legendary podcast, legendary crew. Well, thanks for the feedback there. We do release our podcasts on our YouTube channel, but unfortunately they are audio only. While I know that from time to time it would be really useful to be able to include some visuals to go along with what we're describing in the podcast, unfortunately the scope of being able to do that at the level we would want to do is just a little bit too tricky. So I'm sorry, at the moment they will remain audio only, but check out our YouTube channel because we do have a massive range of in-person interviews there with a bunch of B-roll that really fills in the blanks about what we're talking about. Thanks for your comments there, and if you get in touch with your t-shirt size and shipping details, we'll fire a fresh tee straight out to you. All right, that concludes our interview, and before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.